Welcome to the class, dear students. Today we are going to do non-linear Bernoulli's differential equations. So in this topic, we are going to make the differential equation, transform the differential equation which is non-linear to linear using some strategy. So let us see, in the last lecture I have done how to solve the linear differential equation. In the last lecture we have done this type of problems. So we made them as by finding out the integrating factor and then finding out the general solution like this. So now we are going to do how to solve the non-linear differential equations. So the standard form of nonlinear Bernoulli's differential equation is given by dy by dx plus p of x into y is equal to q of x into y power n. So what we do is, strategically how we do is, we always divide the equation because the linear equation doesn't consist of y power n, right? So on the right hand side, we will just try to form that u of x alone. So divide by y power n on both sides of the equation. So what we get here, it is y raised to minus n dy by dx plus p of x times of y power 1 minus n is equal to q of x. So this is what the equation. And now when you say this equation, what we do is we just make a substitution. Always any problem it is, so we wanted to make it as linear, right? So we wanted to make this as the substitution, as so that the derivative of this gives you this is term. First we take this as a substitution. The derivative of this term gives you this term. So let us see how it is possible. Substitute some u is equal to y power 1 minus n. Then what is the derivative of u with respect to x? It is given by 1 minus n times of y power 1 minus n minus 1 dy by dx. This is what the substitution. This is what the derivative. Then this 1 and 1 gets cancelled. We will be remain with 1 minus n times of y power minus n dy by dx. So in the given equation, what we have is y power minus n dy by dx. Here also we have y power minus n dy by dx with some constant multiple. What we do now is we just divide this by 1 minus n. So that is 1 minus n du by dx gives you y power minus n times of dy by dx. So this is what the substitution. So let us now put all these in the equation 1. So what is y power minus n dy by dx? I can substitute here by du by dx and this term by u. I hope you could understand. I wanted to write this whole thing. Y power minus n dy by dx will be replaced by this 1 by 1 minus n times of du by dx. And what is this term? This term is u. Clear? So now let us substitute all this, plug all these values here in the equation. What we get, let us see. 1 over 1 minus n times of du over dx plus p of x times of u is equal to q of x. So this is some constant, right? So we slowly entered into the standard form of the linear differential equation. Just in the place of y there is u, that's it. So what we do, we multiply by 1 minus n. Because it's a constant, no problem. So multiply by 1 minus n to this equation. What we get? Du by dx plus 1 minus n times of u times of p of x is equal to 1 minus n times of q of x. So we understood that. Now this has become the linear differential equation. This is the linear differential equation in what? In u. So we know how to solve a linear differential equation. We have to find out what is p of x and what is q of x. Okay, p of x is what? 1 minus n times of p of x. And then q of x is 1 minus n times of q of x. then you know how to find out the integrating factor and then finding out the general solution. So this is what the strategy we follow to solve the non-linear, that is the Bernoulli's differential equation. So let us now, we follow the same method now. After finding out the linear differential equation, we can just go to the problem of linear differential equation formula. So let us now start with the problems now. Solve the differential equation dy by dx plus 1 over xy is equal to 3y cube. Okay. Now, what we do now is, since it is non-linear, first of all, what we do? Divide by y cube, the term y cube which is there here, this term, whatever is there, because the non-linearity is what? Y cube only, right? Because of the reason for non-linearity is what? Actually y cube. So we divide by y cube the whole equation. So what we get? Then it is y power minus 3 times of dy by dx plus 1 over x, y power 1 minus 3 is minus 2 is equal to 3. Okay. So now let us now substitute. Now what is the substitution here? Substitute u is equal to y power minus 2. So what is the derivative of u? Is du by dx is given by minus 2 times of y power minus 2 minus 1, which is y power minus 3 dy by dx. So you observe here, this is what? Y power minus 3 dy by dx is can be replaced here. Y power minus 2 can be replaced as u. I hope you could understand. So now what is this y power minus 3 dy by dx? This can be replaced by du by dx. That is what actually here we can write one more step, that it is, because minus 2 is not there. So we write minus 1 over 2 times of du by dx is given by y raised to minus 3 dy by dx. So this is what the substitution. And what is this y power minus 2? Y power minus 2 is what? Is u. Clear? So now let us go to the problem. So we write this as minus 1 by 2 times of du by dx plus 1 over x times of u is equal to 3. So very clear that it has become now linear differential equation. Now what we do? We multiply by, because we need in the, what is the standard form of linear differential equation? Let us compare this with dy by dx, the linear differential equation, p of x into y is equal to q of x. So dy by dx is always alone. So what we do? We multiply by minus 2 to make it as alone, so that we get the equation. That means multiply by minus 2 so that we get du over dx minus 2 over x into u is equal to minus 6. 3 into minus 2 is minus 6. Now when we compare this with you can now compare with this standard form of linear differential equation. So from here what we get? It implies p of x is what? In the place of p of x what we have? In the place of y it is u. Okay, it is u in the place of y. So we write do by x as p of x. So p of x is 2 by x and q of x is p of x is 2 by minus 2 by x and q of x is minus 6. Many students will do the mistake here by taking 2 by x. See here, observe that there is a negative sign. Here there is positive in the standard form. So we should not don't make a mistake that taking minus 2 by x here. Understood? So now let us go to q of x is this. Now what is integral p of x dx? It is given by integral of minus 2 over x dx. So you take minus 2 outside and integral of 1 over x, which is ln x. Now how can we write this? I have already explained you how to write this as ln of x power minus 2. So this we can write. So now therefore what is the integrating factor? The integrating factor is given by e raised to integral of p of x dx. So that gives you e raised to ln of x power minus 2. So that gives you x power minus 2. So this is what the integrating factor. Now we can write down the general solution. What is the general solution? The general solution is, now what we write in linear form, the general solution is what actually we have written now. The general solution is given by y into integrating factor, y times of integrating factor is equal to integral q times of integrating factor into dx. Correct? That is what the general solution. Now similarly, here in the place of y, you have u, right? So the general solution is given by u times of the integrating factor is equal to integral of q of x times of the integrating factor dx plus the constant. So now what is the integrating factor we got? X power minus 2. We can also write this as 1 over x square. So u times of 1 over x square is equal to integral of, what is q of x? Q of x in the equation is minus 6. So we write that minus 6 times of integrating factor is 1 over x square dx plus the constant. So now what is u now? Again we have to replace that u also. U is given by y power minus 2. So let us take that as y power minus 2 times of 1 over x square is equal to minus 6 times of integral of x power minus 2 dx plus the constant. So it is minus 6 times of x power minus 2 plus 1 is minus 1 over minus 1 plus the constant, that is given by 6 over x plus the constant c. So therefore, how can we rewrite this? The general solution is 1 over, I can write this y power minus 2 as y square, correct? So we can write this as 1 over x square y square is equal to 6 by x plus the constant. So this is the general solution of the non-linear, that is the Bernoulli's differential equation. I hope you could understand this problem. Let us now go to the next problem. Second problem is, let us solve this. Dy over dx plus y over x is equal to xy square. So now what is the non-linearity is because of y square. So what we do? Divide by y square. Then when you divide by y square, what is the equation we get? Y power minus 2 times of dy by dx plus y power 1 minus 2, which is minus 1 over x, is equal to x. Okay. So now what we do? We got this equation. So what we do is, just we substitute, we have to substitute what always? The y power, the term which is in the, without dy by dx. So substitute y power minus 1 is equal to u. So what it implies? What is the derivative? That is du by dx is given by minus 1 times of y power minus 2 dy by dx. So now look at the figure, look at the equation. Y power minus 2 dy by dx is du by dx. So what we write? So minus du by dx we can write, right? So minus du by dx is given by y power minus 2 times of dy by dx. So this is what our first substitution. This is what actually is this. Okay. And this is what u. This is what your u. I hope you could understand very clearly, I think so. Now let us go to the substitution. So what is the equation implies now? Therefore, equation can be written as minus du by dx plus u over x is equal to x. We can call this equation as 1. Otherwise, from this first equation, what we get is this. Okay. Now again, when you compare this with the standard form of the linear, now we have slowly entered into the linearity from non-linearity, correct? So what is dy by dx is given by p of x into y, dy by dx plus p of x into y is equal to q of x. Always compare with the standard form of the linear equation. So you understood that dy by dx is always alone. So what we do now? Multiply by minus. So what it implies? Du by dx minus u over x is equal to minus x when you multiply by minus. Now you can understand what is p of x now. What is p of x here? Is minus 1 over x. Again here it is minus, please remember. And there is q of x, which is again minus x. Now we have to find out what is integral of p of x dx. What is integral p of x dx is minus 1 over x dx. Now we know what is integral minus 1 over x is minus ln x. So this is what integral. Therefore, what is the integrating factor? This is given by e raised to integral of p of x dx, that is given by e raised to minus ln x. So we have done already in the linear examples. E power minus m into ln x is given by x to the power of m. This we know. Similarly, e power ln x is given by x. Similarly, e power minus ln x is given by 1 over x. This and all we have done in the linear class when we were doing the linear differential equations we have done. So this can be written as now 1 over x. This is the integrating factor. So therefore, what is the general solution now? The general solution is given by, remember, don't put y, now it is u times of the integrating factor is 1 over x is equal to q of x. What is q of x? Q of x is what? Minus x. Q of x is equal to minus x, correct? Is equal to minus x. So we write integral of q of x is minus x into integrating factor. We got it as 1 over x dx. So this x and x gets cancelled. You will be remain with minus integral dx, which is equal to minus x plus the constant. Therefore, in the place of u, you have to replace what? Our function where u is equal to y power minus 1 is the substitution. So, therefore, y power minus 1 times of 1 over x is equal to minus x plus the constant. So, what is this? 1 over xy is equal to minus x plus the constant. This is what the general solution. I hope it is clear, all of you. So this is what very easily you can change the non-linearity to linearity in a easier manner. Let us now go to the next problem. The third problem is 2y minus 3 times of dy by dx is equal to y power 4 times of e raised to 3x. So this is what the equation. Always compare with the standard form of nonlinear differential equation. What is the nonlinear differential equation standard form? Dy by dx plus p of x into y is equal to q of x times of y power n. This is what the standard form of Bernoulli's equation, correct? So now you can understand that the dy by dx here, where it is here, and p of x into y means you have to take p of x into y as this, p of x into y as this, and then we can write this as like this. Now let us see how it is possible. Now let us go to the problem. So let us now see that it is given by, let us first rewrite the equation, that is minus 3 times of first dy by dx term should be there, correct? Minus 3 dy by dx plus 2y is equal to y power 4 times of e power 3x. So now slowly we are entering into this form, and then Now we don't want, first of all we have to make it as dy by dx and divide by y power 4 first of all. Let us take this y power 4. This should be divided, correct? So divide by y power 4 on both sides of the equation. So that gives you what? Minus 3 y power minus 4 dy by dx plus 2 times of y power minus 3 is equal to e raised to 3x. Understood? Now what is the substitution? Same way. The substitution is u is equal to y power minus 3. So du by dx gives you minus 3y power minus 4 dy by dx. So we can directly substitute this whole thing as what? This whole thing as du by dx and this y power minus 3 by u, correct? And now we will get now it as du over dx plus 2u is equal to e raised to 3x. So it is exactly the standard form of the linear differential equation. So what is p of x here now? It is 2 and q of x is e raised to 3x. So now what is integral p of x? Integral p of x dx is given by integral of 2 dx which is equal to 2x. So now what is the integrating factor? The integrating factor is given by e raised to e power integral of p dx which is e raised to 2x. So we got the integrating factor also now. So now the general solution. The general solution. What is it? It is u times of e raised to 2x is equal to integral of q of x is e raised to 3x. Integrating factor is e raised to 2x dx. So this is e power 5x dx. So what is this? U into e raised to 2x is equal to integral of e power 5x is e power 5x by 5 plus c. Now what is u? U we have replaced as what? Actually y power minus 3 is the substitution for u, correct? So let us rewrite that now in the equation as y power minus 3 times of e power 2x is equal to e raised to 5x over 5 plus the constant. So that is given by e raised to 2x. You can write y power minus 3 as y cube is equal to e power 5x over 5 plus c. So this is the general solution of the equation. Is that clear? Okay, done. Now let us go to the next problem. The fourth problem, it is sin x dy by dx minus y cosine x plus y square is equal to 0. So first we have to divide. First of all, let us divide this whole thing for the standard form. This sin x should not be here, right? So first we divide by sin x and then divide by the non-linearity is because of y square. We divide by y square later. So first we divide by sin x. Divide by sin x. Then what we get? Dy by dx minus y cosine x by sin x, which is cot x. I hope you know, all of you, what is cosine x by sin x is equal to cot x. And 1 over sin x is given by cosecant x. These are the things you know already. So we can write now. So minus y cot x plus y square 1 over cosine x is cosecant x is equal to 0. So now let us rewrite this equation in the standard form as dy by dx plus p of x into y, that means minus y cot x, and we write this as minus y square cosecant x. So now it is in the standard form. So we divide by what? By y square. When you divide by y square, what we get? It is dy y power minus 2 times of dy by dx minus y power 1 minus 2 is minus 1 times of cot x, and y square when you divide it, it is minus cosecant x. Now what we do? We substitute. Same procedure. Substitute u is equal to what? Y power minus 1. So what is the derivative of u? Is y power minus 1 y power minus 2 dy by dx. So you can write the negative sign on the left hand side as dy by dx is equal to minus du by dx. So let us now find out this one. We write this as y power minus 2 dy by dx as what? This whole thing dy by dx as minus du by dx, and y power minus 1 will be replaced by u. Clear? So now let us go back to the equation, which is minus this equation 1, let us say. So equation 1 implies du by minus du by dx minus u cot x is equal to minus cosecant x. So all are minus, so I can change it as plus. So du over dx plus u cot x is equal to cosecant x. Now here what is p of x? Is cot x, and q of x is cosecant x. Now what is integral of p of x dx? Is given by integral of cot x. Integral of cot x is minus ln of cosecant x. So therefore, what is the integrating factor? Is given by e power integral of p of x dx, which is given by e power minus ln of cosecant x, which is given by 1 over cosecant x, which is nothing but sin x. I have already given you what is 1 over cosecant x. So therefore, what is the general solution now? The general solution is u times of integrating factor is sin x is equal to integral of q of x is cosecant x into sin x dx plus the constant. So what is u here? U is given by the function y power minus 1. So it is, can I write this as sin x by y? Y power minus 1 means y, correct? Is equal to, and cosecant x means 1 over sin x. So both of them gets cancelled. You will be remain with dx, okay? Plus c, which is equal to x plus c. So the value, the total solution is what? Sin x over y is equal to x plus c. So this is the solution. This is the general solution. I hope you could understand. Try to not to do any mistakes in the examination. So generally when you do, the mistakes are, you may put minus here, and so you may put plus here as p of x, and if you find out like this, suppose, then definitely you will be committing a mistake, and then you will be committing in the integrating factor, you will not get the same. Once the integrating factor is different, then definitely the solution will be different, and hence all this goes on. Understood? So with this I will conclude the lecture. So try to listen, watch the lecture nice, and try to understand the concept and do the exam very well. Thank you.